Hi, this is Nimla Rednam. In this video, we are going to solve the sums of exercise 9.2. We are currently dealing with the chapter Mensuration, which is the 9th chapter from NCERT textbook class 8. In the previous two videos, we looked at the theory part where we derived the formulae for finding out the surface area of solid shapes like cube, cuboid and cylinder. This exercise deals with a few problems of where we will be using these three formulae and getting the finding the surface areas. Now let's look at the first question. There are two cuboidal boxes as shown in the joining figure. Which box requires the lesser amount of material to make? So you can see that the boxes they have given here are, the first one is a cuboid, right? And the second one is a cube. Let's write it down. So I have the first one is a cuboid, right? So what are the dimensions here for the cuboid? 60, 40 and 50. 60, 40 and 50. So whenever the dimensions are given to you for a cuboid, this is the standard this is a standard representation of that. Basically this is length and this is breadth. We assume, okay, that the first dimension is the length, the second is the breadth and the third one is the height. Now how you read it is L by B by H, that is 60 by 40 by 50. These are the dimensions of the given cuboid. Now they're asking us, of the two, that's the cuboid and the cube that they have given, which one requires lesser amount of material to make? So material to make is nothing but the surface area. To be more specific, it is the total surface area, right? So that is the amount of material you will need to in order to make that box, right? So what we'll be finding out is the total surface area, and we know that for a cuboid the formula is twice of LB plus BH plus HL. So let's do that quickly. LB is 2400, BH is 2000 and HL is 3000, and the units are centimeter square. So if you add this 7,400 into 2 is nothing but 14,800 square centimeters, right? So this is for the cuboid. Next, they have given a cube. How do we know it's a cube? Because all the three dimensions LBH are the same 50 centimeters. Therefore, it's a cube. Now, for a cube, what is the total surface area formula? 6L square or 6A square, right? So, the second one is a cube, 50 by 50 by 50. So, I'm going to write the total surface area as 6L square centimeters, right? This is 25 into 6. 25 into 6 is 150 and then 2 zeros. So I have 15,000 square centimeters. So to answer the question, they're asking which one requires lesser amount of material to make. So clearly the cuboid requires lesser amount of material to make. This is less than 15,000. So the answer is the cuboid requires lesser material compared to the cube, right? So that answers our first question. Second question, a suitcase with measure 80 by 48 by 24 is to be covered with a tarpaulin cloth. How many meters of tarpaulin of width 96 centimeters is required to cover 100 such suitcases? So you have the cover for the suitcase and they're giving you the dimension of the suitcase. So the dimension given is 80, 48, 24. 80, 48, 24, right? So this is L, B, H. So now they're saying how many, you have a tarpaulin width is given and how many meters of it do you need to make 100 such suitcases. That means first I need to calculate the total surface area of one suitcase, right? Once I have total surface area of one suitcase, I am going to multiply it with 100 for 100 suitcases, and that is going to be the area of the rectangle whose width is 96 centimeters, right? So let us do that. So first of all, I need the total surface area for one suitcase. I'm considering one suitcase, right? So I have twice of LB plus BH plus HL. So 48 into 80 is going to give me 3840. Okay, you can calculate and check. And then I have 48 into 24, correct? 48 into 24 is going to give me 1152, and then 24 into 80, which is 1920. Okay, so it's just a little bit of calculation you need to do here. So I have 2 into 6912 square centimeters. So this is for one suitcase. I'm going to leave it like this because we anyway, this is not the final answer and they didn't ask us to find work for one suitcase. It will be easier for me to simplify it if I leave it, over here. So for 100 suitcases, the total surface area will be into 100, right? So for 100 suitcases, total surface area is 100 times of 2 times of 6912 square centimeters. Okay, now they're saying that you have a tarpaulin whose width, this extends. I need to find how much length I need. Width is given as 96 centimeters, right? So now this 96 into this width is the area of this tarpaulin, rectangular tarpaulin, that I need to make total these many suitcases of this area, right? So I'm going to equate these two, right? So 96 into the length of the tarpaulin is equal to 100 into 2 into 6912. So therefore L is equal to 96. I'll write it as 12 into 8. Now I'll do the simplification. I have 6 tables, 6 ones, 6 ones, 6 fives, and then 6 twos. And then if you consider 8 table here, I'm going to get 8 ones and 8 fours and fours. And it's going to be centimeters. So I have 14400 centimeters, which is nothing but 144 meters. So this is the length of the tarpaulin that is required, right? So this is the second question. The third question, find the side of a cube whose surface area is given as 600 square centimeters. So if the surface area is given to us, I know that for the cube it is 6L square, is given as 600 square centimeters, right? So L square is equal to 100. That means L is equal to 10. Square root of 100 is 10. So the answer is 10 centimeters, right? Next question. Rukhsar painted the outside of the cabinet of measure 1 by 2 by 1.5. How much surface area did she cover if she painted all except the bottom? Now you can see they have given the figure. Even otherwise, like I told you, you will take length, breadth and height in the same order, as in 1 is your length or breadth and 2 is your breadth and 1.5 is your height. So she's painted everything but the bottom, right? So let me write the dimensions first. 1 by 2 by 1.5. So the dimensions are meter 1.5. So this is LBH. Now what will the bottom be? The bottom is going to be LB, right? So that I need to exclude. So my surface area is going to be the top. The top is also LB. So that I'll take as 1 into 2. And the rest is going to be 2 times of uh, 2 into 1.5, which is 3, and 1.5 into 1, which is 1.5 meter square, right? So here I have 2 plus, this is 4.5 into 2 is 9, right? Which is nothing but 11 meters square. Now, this is the surface area and this is the answer, required answer. Next, Daniel is painting the walls and ceiling of a cuboidal hall with length, breadth, height as 15, 10 and 7 meters respectively. From each can of paint, 100 meters square of area is painted. How many cans of paint will she need to paint the room? So let me scroll it up. Right. So now they're asking us, they have given the dimensions, right? And they're painting the room, they're painting the walls, the 4 walls and the ceilings, right? So they have given clearly the walls and the ceiling as well. Okay, obviously floor won't be painted. So again, you're going to take just like the fourth sum, we're going to have only 6 faces. Out of the 6, we are going to have only 5 faces that are painted. So let's write down the dimensions first. This is the 5th question. The dimensions are 15, 10 and 7. So I have 15, 10 and 7. So this is my L, B, H, right? And so I'm going to exclude one floor, that is LB. So my surface area is going to be, the ceiling is LB 150 plus 2 times the other 2, which is 70 plus 15 into 7 is 105 meter square, right? So this is 175. 175 into 2 is 350 and plus 150 is 500, right? So the surface area that is painted is 500. One can gives me 100, right? So 5 into 100 is 500. So I need 5 cans. How many cans do I need? 5 cans are required to paint the room. Next question. Describe how the two figures at the right are alike and how they are different. So you can see that they have given two figures. The first one is a cylinder. The second one is a cube, because length, breadth and height are all of same dimension. So it's a cube. So what is the similarity? You can say that the height is the same. So the similarity is that same height. They are of same height. What is the different? They are different solid shapes. Okay, they are different solid shapes. One is a cylinder, and the other is a cube. Okay, and the second one is a cube. So that is the difference. Now next they are asking us, which box has larger lateral surface area? They have mentioned very clearly, be very careful, lateral surface area. So you're going to take only the lateral surface area formula. We are not interested in the total surface area, right? So now I have for the cylinder, you know that the formula, cylinder and cube, right? Lateral surface area is 2 pi RH and for the cube it is 4L square. So here it is going to be R. What is the radius of the cylinder? The diameter is 7, so the radius is going to be 7 by 2. Okay, and height is 7. And over here it's going to be 4 into 7 into 7. So here if you simplify, so this is 7, I'm going to write 7 here. So 7 into 22 is 154 square centimeters. 49 into 4. 49 into 4 is 196 square centimeters. So these are the respective lateral surface areas. And which one has larger? Clearly 196 is greater. So the cube has larger surface area, lateral surface area. Larger lateral surface area. So that is the answer. Next question. The seventh question. A closed cylindrical tank of radius 7 meters and height 3 meters is made from a sheet of metal. How much sheet of metal is required? Now they mentioned closed very clearly. They're saying closed. That means you're going to have a base and a top as well for the, it's a tank, so you need to have base and top. So it's going to be the total surface area. What are the parameters given to us? Radius is 7, height is 3. So let's write it down. I have radius is 7, height is 3. And what is the total surface area formula? 2 pi r into r plus h, right? So 2 into 22 by 7 into r is 7, r plus h is 10 meters square, right? I can cancel these two. I have 440 meters square. So that is my total surface area. So that is the amount of metal sheet that is required. Next question, the lateral surface area of a hollow cylinder. Now what we mean by hollow cylinder is you don't have base and top. So you're talking about lateral surface area there. It is cut along its height. You know that you will get a rectangular sheet. We have seen it in the previous video. If you are going to cut it along its height, you will get a rectangular sheet. Width is given to us. Find the perimeter of the rectangular sheet. Let's carefully write down all the information given to us, right? So the eighth question, lateral surface area is given to us as 4224 square centimeters, right? And once you cut it, the width is given as 33 centimeters. Okay, now this is the cylinder and you're going to cut it along the, along the height. You're going to get a rectangular sheet. Now for this they have given the width, right? So the width of this is nothing but this length, correct? This is given as 33 centimeters, right? So if this is 33 centimeters, width is given as 33 centimeters. Find the perimeter. Can you find out, first of all, can you find out the other, if I want the perimeter, I need this measurement, right? I need this length. So can I find it out from the given information? Let's look at that. You know the formula for lateral surface area is 2 pi r h, correct? So now if I equate 2 pi r h is equal to 4224, and what is 33? This is nothing but the circumference of the circle. So this part is nothing but 33. So I can write h as 4224 by 33, right? So if I simplify this, 311 table, I'm getting 128 centimeters. So that is your length of the, the length, this dimension of the rectangular sheet. Now they're asking us the perimeter. Perimeter is twice L plus B, which is nothing but 128 plus 33 is 161, and twice of that is 161, so 322 centimeters. So that is your perimeter. That is what they're asking us to find. So let's look at the next question. A road roller takes 750 complete revolutions to move once over to level a road. They have given the figure. Find the area of the road if the diameter of the road roller is given and the length is given. So if you look at it, they are giving you the, you can see from the figure that this particular road roller, the part which is going to do the job, it is cylindrical in shape, right? Now they're saying that the diameter is given, that means I already know the radius of the cylinder, and the length is given. Length of the road roller is nothing but height of the cylinder, right? Only thing is you need to be very careful here is that this is given in meters. I need to, and the radius is in centimeters. So I'm going to convert this into centimeters, the height. Okay. So the length in this particular question, it's nothing but the height of the cylinder that we use in our formula. So these two are given to us, right? So let's look at now when the road roller is, rolling over the, surface, the part that comes in contact with the road to level the road, that is only the lateral surface area, right? And for the cylinder, lateral surface area is 2 pi RH. R is given as half of 84 is 42, and H is nothing but the length they are talking about, which is 100 centimeters. Okay, so I know that for one revolution, the surface area it covers, okay, is going to be 2 into 2 pi RH, right? 2 into 22 by 7 into 42 into 100 square centimeters. So this is nothing but I have 44 into 6, right? 44 into 6, 464, and then 2 zeros, correct? So this is what you cover in one revolution. 264, 24, right? 24 plus 2 is 260, 26. So 264 100 square centimeters. Now I'm going to make 750 such revolutions. So I'm going to get 750 into 26400, which gives me a total of, so that is 198 and 3 more zeros. I'm going to convert it to meter square. 1 meter is 100 centimeters, so I can get rid of 4 zeros here. So I have 1980 meter square. So this is the area that the road roller is going to cover, right? That is the question they're asking. Next, 10th question. That's the last one. A company packages its milk powder in cylindrical container whose base has a diameter of 14 centimeters and height is 20 centimeters. Company places a label around the surface of the container. If the label is placed 2 centimeters from top and bottom, what is the area of the label? Okay, so now here you are talking about the lateral surface area clearly, because the label is covering only the lateral surface area and also not the entire 20 centimeters height, only a part of it. Okay, so for my label, the measurement is going to be the R and H. The corresponding R and H are going to be, R is the same as the can, which is R is given as 7 because D is 14, so R is 7, and the height is going to be, now you have 20, out of which 2 centimeters each on top and bottom you're going to deduct, which is 4, so you'll get 16 centimeters. So the lateral surface area is 2 pi RH, which is 2 into 22 by 7 into 7 into 16. Right? So you have 16 into 44, which will give you 704 square centimeters. So that is the required answer. So with this, we finish all the sums from exercise 9.2. And in the next video, we will start discussing the volume of solid shapes, and these three that we have considered even for 9.2, we will be looking at cuboid, cube and cylinder. So like in a two-dimensional figure, you have a perimeter and area. For three-dimensional, we have the surface area and the volume. So we will be understanding what we mean by volume of a solid shape, and we will look at the formula for these three standard solid shapes.